Assalamu alaikum dear students. Today we are going to discuss the footing design example. That is basically it is a square footing design example we are going to discuss. And then example 12.2 it is dictated that is the design a square column footing for a 16-inch square tied interior column that supports loads of D, that is the dead load is 200 kilonewton kilo, and here the live load is 160 kg. The column is reinforced with 8 numbers of 8 bars. The bottoms of the footing is 5 foot below the final grade. The soil weight is 100 pound per feet cubic. The allowable bearing the soil pressure is 5 ksf. The concrete is strength is 3000 psi and the steel grade 60,000 psi. So this is the example we are going to discuss, the complete design of foundation for a square column. The column dimension is given, the 16 inch by 16 inches, and the reinforcement in the column is with 8 numbers, that is 8 numbers, 8 bars. So that is why number 8 bars. And the footing depth is given here 5 feet below the final grade. So this is the data for which we are going to design a foundation for a square column. Now, as I already explained in the design of wall footing, we have to calculate what is the first we have to assume what are the thickness and then calculate what are the footing weight and soil weight. The first, generally we are going to assume that is the footing thickness is 24 inches. So we already told in the previous slides that the footing depth should not be less than 12 inches. So here we are taking the footing depth is equal to 24 inches with a cover of 3 inches. This gives the D value is 19.5 inch. So this means it's up to you. You can take 3 inches, you can take 3.5, you can take 4. It depends on you how many covers, how minimum covers you are taking. If it is mentioned, you have to take that covers. We already explained that is the effective depth is 19.5 because 24 minus of 3 minus of 1.5. So you can easily you can take it 24 minus of 4.5. It is 19.5. Compute the footing weights and soil weight. You have to calculate the following. So this is the figure. This is your footing of this dimension. It is not given, so that is why we have to calculate the dimension later on. Suppose this is your footing and this is your column, and which is 8 column. It is written that the 8 numbers reinforcement which is provided in the column. The footing depth here 5 feet below this. There is a PCC, we can take 2 inches PCC, but PCC not included in the footing depth. So that is why the depth of the footing from here the ground level to this level it is given in the 5 feet in the questions. We assume the 24 inch is the footing depth, so whatever the left, because the total is 5, so this means if you change in inch it is coming 60. So this means 24 minus 60 minus 24 it will come 36. So what is the footing weight which is acting, this footing weight which is acting to the soil, that is 24, you have to convert into feet multiplied by 150, it is coming 300. And here 36, this is the soil divided by 12, that is you have to convert it to inch into feet and multiplied by 100, it is coming 100 is the soil weight, 150 is the concrete weight. So this means this is 300 pounds. So what are the effective, because these forces which is acting on the down, so this means what are the effective pressure which is acting on the soil, you have to calculate the effective pressure, because it is 5 ksf, it is given here 5 ksf is, so this means 5000 sf. So this means here 5000 psf minus of 300 minus of 300. So this is 300 and this is 300. It is coming 400 psf. Now earlier we explained that while calculating the area of the footing, we don't have to multiply it by the factor of safety to the dead load as well as the live load. So what is the dead load here? It is given 200 and the live load is given 160. So this plus this divided by 4, it is coming 81.82. And here it is coming 9.1 and 9.2. If you take the under root of this, it is coming 9.01 like this. So we are taking that is the 9 feet by 9 feet. Maybe it is little bit less or more, it doesn't matter. Okay, so it should be approximately equal to this, maybe little bit less, little bit higher, but you have to take the round. It should not be 9.3, 9.2 like this. It should be 9.5, it should be 10 like this. You have to take this for easy construction. So already you fixed your foundation 9 feet by 9 feet. So this is here, that is 9 feet by 9 feet. This is the width of the footing and this is the length. So this means 9 feet by 9 feet is your foundation, you already decided. Now you have to calculate what are the actual bearing pressure which is acting on the foundation, because you provide 9 feet by 9 feet, the area is 81, and here for calculating the actual pressure you have to multiply it by the factor of safety. So 1.2 multiplied by 200, 1.6 multiplied by 160, it is coming 6.12. Here soil bearing pressure is coming 5, but the actual soil bearing capacity for soil bearing pressure which is acting on the soil is 6.12. For this force, for this soil pressure, you have to design your foundation. Now because we already know that the foundation depth governed by two-way shear as well as the one-way shear, so we have to calculate what is the two-way shear and what is the one-way shear, and we have to check whatever the footing we provided 12 inches to 24 inches footing, whether this footing is safe or not. So the critical section, this is your column in between here, and this is your foundation. The foundation is 9 feet by 9 feet, and the column is here 16 inch by 16 inch. So this means the critical section of the foundation is for two-way shear, it at a distance d by 2 from the face of the column. So d by 2 here, d by 2 here, d by 2 here, and d by 2 here. So this means this is the area. The length of this is the column dimension 16 inch plus d by 2 half depth here, the total depth, one depth, it is coming 2.96 feet. This is inch, if you convert into feet it is coming here. So this means this length is 2.96 feet, 2.96 feet, 2.96 feet, 2.96, because this is the two-way shear. If the load is applied to the soil, it will bulge out. This shaded portion of the foundation will come up. So this means we have to calculate what is the shear force acting on this shaded portion. How you will calculate? That the total area minus of this area, you will find this area, shaded area. So what is the shaded area? The total area 9.9 feet, and then here the shaded area 2.96, 2.9, it is coming 72.23. So we know what is the soil upward pressure and on what area this is going to be act. So we have to calculate what is the two-way shear. Two-way shear B naught is the parameter of this. B naught is that this length plus this length plus this length plus this length. So the 4 plus 16.3, it is the B naught value. So first we have to calculate B naught, 4 multiplied by 16, 19.5. So V2, that is the shear force we have to calculate. How you will calculate the shear force? Shear force, that the total area 9 by 9 minus of this small area, so that is 2.96, 2.96, this is the area multiplied by soil pressure, we calculated 6.12 here. So here we found that the two-way shear which is acting on the foundation is 442.09. Now from the formula, here it is given here here in the formula it is given here VC is equal to 0.5D. Based on this two-way shear, you can easily calculate what is D here. This is VU, D is equal to VU 0.75, 4 under root 3 psi 142, that is B naught. It is coming 18.95 and we provided 19.5. This is okay. In the second way, formula also for calculating the D for the two-way shear, here it is written here, that is this 2 alpha S and all these things, or 2 4 beta BC, you can calculate from this formula also. If you assume this formula here also, if you apply this, all these things value here 142, it is coming 10.1. If D is coming from this, it is safe already. From D it is already safe. So this means here it is coming 18.95, which is less than, here it is coming 10.12, which is less than 19.5. So this means our footing is safe in two-way shear. Now we have to calculate what is one-way shear. One-way shear, we have to calculate the depth one-way shear. One-way shear, the critical section, it at a distance D from the face of the column. So this area you have to calculate. What is this area? So first you have to calculate what is this length. This length is equal to 4.5 because the total is 9 feet. So half of this is 4.5 feet. So 4.5 minus of this, that is the total is 16. So this means half of this column is 8 inch divided by 12. We have to convert into feet, and D is equal to 19.5. It is coming 2.80. So what is one-way shear? This length multiplied by this length. and multiplied by 6.12. So you will calculate the 9 feet 2.08, and then here it is coming here. In the same formula for one-way shear, if you see from here in the theory, that D is equal to VU divided by alpha 2 under root 3 108. 108 is the inch B. B is equal to, because total is 9 feet, if you multiply it by 12, it will come 108. So B here you have to put B in terms of inch, not in terms of feet. It is coming 13.71, which is less than 19.5. So this means our footing is safe in one-way shear as well as the two-way shear. Now we have to calculate the moment. For moment, we already explained to you that is the critical section for the moment is the face of the column. So we have to calculate this length. This length approximately, that is the 9 by 2 minus of half of column, that is 8 by 12 inches, that is 3.8 feet. So because this is a cantilever, so if soil pressure is acting here, so this means W into L by 2. So this means WL square by 2. So 6.12 KSF 9 3.83 feet square divided by 2, it is coming 404 kilo feet. And based on this, as you already explained, I explained to you how to calculate the reinforcement. Based on this, the first we have to calculate two-way shear. Then you have to check whether our depth of the footing, whatever we assume, it is safe or not. If it is not safe, you have to increase the thickness of the footing. If it is safe, there is no need. Then you have to calculate one-way shear, and you have to check whether footing is safe in one-way shear or not. If it is safe, then it is okay. If it is not safe, then you have to provide, you have to increase the depth. Here you cannot provide the shear reinforcement, because this depth only you have to increase to take care of all shear, one-way or two-way shear which is developed in this. It should be safe from them. Okay, then calculation of moment, you already calculate mu over 5 BD square. So B is 108, means 9 feet. D you know everything, it is coming 131.2. So this means from the figure, if you see here, that is the minimum reinforcement rho is equal to 200 by this is 0.003. So this means here the minimum, I think from the table, the minimum reinforcement is coming 0.003, and this reinforcement from the table, from this point of view, if we 1.312, that is that is 131.2 C, it will come, that is 0.0025. The minimum reinforcement, there is no need to calculate all this. So we know the minimum reinforcement is 0.003, which is more than this, so you have to provide the minimum reinforcement. So AS is equal to 0.003 multiplied by 108 multiplied by D, it is coming 6.95. And then from the table data sheet, you can find out, use 9 number 8, that is AS is equal to 7, which is little bit more than this. So this is this reinforcement provided in both direction, that is use 9 number 8. So number 8 bar 9, 1 2 3 4 5 6 7 8 9 here, and 1 2 3 4 5 6 in this direction, 9 here, number 8 bars. If you see this here, 9 number 8s, 9 number 8s. So this means in this direction also, this is 9 feet. So you have to, if you want to find the spacing, to 9 feet divided by 9 number, you will know the spacing between this. So 9, 1 2 3 4 5 6 7 8 9 in this, and 9 in these directions also, number 8 bars, and your depth is 24 here and 36 here. So this is all about the reinforcement details for the footing. It is okay. And if your footing, whatever, first initially you can assume 24 inch. If it is 24 inch is failed, it is not coming in one-way shear and two-way shear, you have to little bit increase the depth of the footing, and the same procedure you have to follow while designing the that is the square column footing. Thank you very much. If you have any questions, you can ask me anytime on WhatsApp.